Okay, in Unit 1, Objective 4, we are looking at analyzing piecewise functions and solutions to functions. And so we have some vocabulary we want to get out of the way here at the beginning. There are 6 terms total that we want to make sure we are good with. First one is increasing. What does it mean to be increasing? It means that a function is increasing on an interval when the y values increase as x increases. And so an increasing function would be one that goes up as you go from left to right, because your y values here would be getting bigger as your x values get bigger. And so that'd be an increasing function. A decreasing function is the reverse. A function is decreasing on an interval when the y values decrease as x increases. So it'd be going down as we read our graph from left to right. And constant means that the y values stay the same as x increases, and so a constant graph would be one that is flat as you read your graph from left to right. Okay? And then at the connection points between these different ideas of increasing, decreasing, constant are relative maxima and relative minima. So relative maximum, by the way, is the singular version. Plural, you will sometimes see written as maximums, but the other way you could see it is as maxima. Same with plural of relative minimum, relative minima. And so if you do ever see that that form there, okay, that would be the plural for relative minimum. Okay? So relative maximum is the point at which a function changes from increasing to decreasing. And so a couple of things here. First off, it does say the point at which. If you are looking at a place where you think that kind of looks like a relative maximum, but if you don't see a point, then that is not a relative maximum. Okay, so it is a point at which the function changes from increasing to decreasing. And so that could be like a literal kind of point in the graph there, maybe an upside down absolute value, or it could be a curve, right, like an upside down quadratic, and so that point right in there would be where your relative maximum is located. What it cannot be, though, is something like this, right? This is not a relative maximum, because this isn't a point at which the function changes from increasing to decreasing. Here my function is increasing and I reach a point, but then it's constant reach a point decreasing. Okay, and relative maximum is when we change from increasing to decreasing, so automatically increasing to decreasing, increasing to decreasing, right? And then a relative minimum is the reverse, right? The point, again, emphasis on point there, at which the function changes from decreasing to increasing. And so right there would be your relative minimum. Okay? And then last bit here, vocab. We use this a little bit with domain and range, but we're talking about it again. Open interval means neither end is included. We use parentheses here. That's going to be important when you're reading directions. If the directions don't specify, you will do brackets when there is a point and parentheses when there is not a point, the same way that we have done with domain and range. Okay? But with your directions that specifically state use open intervals, or it'll say state the open interval, or something like that. What is the open interval where my function is increasing? If the directions say to make them open, you better make sure they're open, right? You're following the directions always. Okay? Okay, so in today's notes video, we are going to do a couple here with this, and then you'll notice as I walk through, I'm going to skip some of them because we're going to do some more practice with them in class. Okay? So, example 1, answer the following questions about the piecewise defined function below. A, state the open intervals on which f is increasing. Okay, so go ahead and pause for a moment here and think, what does it mean for a function to increase? Okay, remember, a function increases when my y value increases as my x increases, aka my graph is going up as I go from left to right. And we are going to be writing these as open intervals. So no matter whether there is a point or not, when I identify an interval where my graph is going up as I go from left to right, I will be writing it as open intervals. I'm following directions. Okay? We'll take a look at this graph. The first place where I'm increasing is this segment right here. Right? Again, as you go from left to right, should be going up as you go from left to right. Decreasing is going down. Right? And so as I go from left to right here, this graph initially is increasing. So for how much of that interval is it increasing? Well, it's increasing the entire time, which means where is it starting? There's an arrow, so it's going to negative infinity. Okay? And then where is it ending? Okay, well, it's increasing all the way to that point. Now, this is important here. When you're naming your intervals, because we are reading from left to right to figure out whether we are increasing or decreasing, we name, so maybe I'll put that up here, name using X values. So that negative infinity that I put for over here isn't because the arrow's going down, it's because the graph's going left. It's also going down, but it's going left to negative infinity. And as then I work my way across, just like I would for domain, the graph is going up, 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 up to that point, which is at x equals 1. And then at that point at negative 1. At that point, which is at x equals negative 1, my graph starts to go down, and so that would be a decreasing interval. Okay, and so take a look at this. There is one other interval where my graph is increasing. What is that interval? Okay, my graph is going down, 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 decreasing, decreasing until x equals 1, where my graph turns around and starts going up again, up, 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 until that point, which is at x equals 3. And again, I know there's a point at x equals 3, but remember, we're following directions, open intervals, so we don't care that there's a point. Okay, B, state the open, so again, we are using parentheses, intervals on which f is decreasing. Take a look at this graph. What do you think the interval is where f is decreasing? Okay, well, f starts decreasing here, right? This was at x equals negative 1, and it's going down, 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 all the way to this point at x equals 1. Is there anywhere else where the graph is decreasing? And the answer is no, right? We went down, 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 then up, 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 and then flat. Which brings me to my last question here. Well, I should say my third question, the last of this set. State the open intervals on which f is constant. Okay, well, constant, remember, means we are flat here. My y stays the same as x increases. Where does that happen on this graph? Well, it starts right here, which is at x equals 3. And again, open intervals, so we're doing parentheses. And it's flat all the way till what x value? Well, there's an arrow pointing right, and so it would be infinity. Okay, domain and range. This is a review from 1.1, so I would highly recommend pausing the video, trying these two on your own, and restarting it when you're ready. Right? Use it as a little bit of a review for yourself here. Okay, domain are x values. So what's the smallest x that I hit here? Again, I've got an arrow pointing infinitely left, so this would be negative infinity. And then as I work my way across, I've got points everywhere. Points, 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 points. Uh-oh. I've got a hole. And so I have to stop there. At x equals 1, I don't have a point anywhere on this graph at x equals 1. Okay, and then where does it pick back up again? Well, it picks back up again at 1 and goes all the way x values till what? Till infinity. Okay, range. Range, what's the lowest y value you hit? Okay, well, there's an arrow here. It's tempting to want to say -2. We see that point here, but remember this arrow is pointing down, meaning this graph keeps going. The lowest y value is -infinity. And then as you work your way up, we've got points, 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 points. Kind of looks like there's a hole here, but over here we do have a point at this y value of y equals -2. So I do have a point at y equals -2. It's just over here instead of over here. Keep going up. I've got points all the way until that coordinate point, at which point there's no other points above it. What is that y value? Okay, it's 3. And is it a parenthesis or a bracket? And that would be a bracket. Okay, E, state the coordinates of any relative minimums of f. Okay, well, relative minimum, okay, is the point at which the function changes from decreasing to increasing. It looks like a little valley there, a small spot, right? Minimum, smallest, so it's the lowest point. But again, the point at which, take a look at this graph. A lot of people want to say that 1, -2 is a relative minimum because we see that valley shape there. However, there's no point there. I can't write 1, -2 as a coordinate point. 1, -2 doesn't exist. If that was filled in, then I could write 1, -2, but I have no point there. What about relative, oh, I'm going to put NA, not applicable. What about relative maximums? What are you thinking? Okay, well again, relative maximum, looking up above, it is the point at which the function changes from increasing to decreasing, so this little mountain here. Okay, and so where would my relative maximum be on this one? My relative maximum is right here at -1, 3. So coordinate point, right? Name the coordinates. -1, 3 is the coordinate point. Okay, if there are questions on any of those, write them down now, right? So that we can talk about them in class. We're going to skip that example 2 for a bit, and let's take a look at example 3. Okay, we're going to do examples 3 and 4 actually. Okay, because we have 2 other kind of vocab terms here that we need to take a look at. The first one is X-Intercept, second one is Y-Intercept. And I would say a lot of people are more comfortable with Y-Intercept. X-Intercepts frequently are where these are a little bit trickier for people. First reason why is because this has another name. It actually has 2 other names. X-Intercept, root 0. All 3 of these could be used to ask the same question. You could be asked to find the X-intercepts, or you could be asked to find the roots, or you could be asked to find the zeros. And we need to know automatically that those 3 names are all equivalent, right? They are all synonymous. Okay? With your X-intercepts here, or your roots or your zeros, you're looking at where does the function cross the x-axis. And you'd be naming that point. The other way that they could ask this question besides these 3 vocab words are these 2 questions. Where does y equal 0? If you see that question, where does y equal 0, it's asking you where you touch the x-axis, which makes sense, right? If you think about a graph, if I asked you to graph the point 3, 0, right, y equals 0 there, where would you plot that point, 3, 0? If we were to plot that point, we'd plot it at 1, 2, 3, somewhere out here, right? On the x-axis, an x-intercept, aka root, aka a 0. Okay? And then the final way, which is just kind of using the other name for y, which is f of x, you could be asked to find where f of x equals 0. Okay, Y-intercepts, not usually so tricky, although they still can trip some people up if you're not careful. But thankfully they only have one name, and that's why usually, like I said, people usually do a little bit better with this one. It's where the function crosses the y-axis. It's where y equals f of 0 or where x equals 0. These are two other ways they could ask that question. Both of these are saying x equals 0, by the way. This literally says x equals 0. This here, f of 0, this is usually like f of x. This is saying that my x is 0, x equals 0. So it's two different ways of writing the same thing. And that's asking us to find our y-intercept. Where do we cross the y-axis? And again, it makes sense if you think about graphing a point where x equals 0, like 0, 5. Okay, where would you graph 0, 5? Well, 0, 5 would be like 1, 2, 3, 4, 5, somewhere up here, right, which is your y-intercept. Okay, so example 3 here, working through this together. This goes back, and again, we're going to do 3 and 4, goes back to Math 1 or Honors Math 8, depending on which one you came from. These would have been part of your Unit 4 for both, whether you were in Math 1 or Honors Math 8, would have been part of your Unit 4. And so a couple of kind of quick reminders here before we get started. 1, what does it mean for a point to be a solution to a line? And we talked about this a little bit with inequalities, right? To be a solution to an inequality means it lies in the shaded region. Well, with a line or a quadratic, some curve, you don't have a shaded region, so where would your point lie? Okay, it would lie on the function. To be a solution to a function means it sits on the function. Okay, and again, that would have been looked at back in Math 1 or Honors Math 8. Okay. Okay, so let's go ahead and work through these. A, list the labeled points that are solutions for f of x equals 0. Okay, and so again, we just talked about this. What does it mean to be a solution for? Okay, it means to lie on. And in this case, we want it to lie on f of x equals 0. What does that mean they're asking us to find? Okay, well, for f of x to equal 0, means they're asking us to find an x-intercept. And in this case, it's the f of x-intercept. So we're looking at this curve. Right, that's f of x right here. So what points lie on f of x when it equals 0, aka what points lie on f of x at its x-intercepts? And what would you say? Okay, well, f of x x-intercepts are A, that point, which isn't labeled, so I'm not going to put anything for it, and G. Okay, B. List the labeled points that are solutions for g of x minus f of x equals 0. Okay, so go ahead and take a hard look at that g of x minus f of x equals 0. What does that mean? For g of x and f of x to subtract from each other and automatically equal 0, what does that mean about g of x and f of x? Okay, it means that they are equal. Okay, this is also something that is from Honors Math 8 or Math 1 originally. What did it mean for a point to be a solution, so lying on, where g of x equals f of x? Okay, well, for two lines to equal each other, or in this case for a curve and a line to equal each other, it means that they have to touch, right? They have to be at the same location. So this point here is a place where g of x equals f of x. This is another point, and this one. Only one of those is labeled, and so that's the one that we put. Okay, C. List the labeled points that are solutions, so lying on where x equals 0 on the graph of f of x. Okay, what does it mean for x to equal 0 on the graph of f of x? Okay, x equaling 0 is a y-intercept, right? It's the second box here. So what are the points that are lying on solutions of my y-intercept on F? Well, here's my y-axis. There are two y-intercepts. One is D, one is C. Which one goes with f of x? Remember, f of x is the curve, and so it would be C. Okay, D, list the labeled points that are solutions for, so lying on f of x. All right, so very direct. List the points that are lying on f of x. Well, here's f of x. What are the points lying on f of x? Well, we have A, C, all the way across here, E, F, and G. All five of those points are solutions for f of x, lying on f of x. Okay, and last one for this example, list the labeled points on f of x that are solutions for f of x being less than g of x. In inequalities, we talked about what that meant, right? F of x is below g of x. So we're listing the labeled points on f of x, so only the ones that are on f of x, where f of x is below g of x. Okay, so let's go ahead and take a look at one of our first points here. A is on f of x, right, on f of x. Is this A below g of x? Okay, well, this g of x is here, and so yes, it is. A is one of our points. Working our way across, what about C? C is on f of x. Is C below g of x? C below g of x? No, it's not. It's above g of x here. Working our way across, then we have E. What about E? Well, E, yes, E is below g of x. We have F. Nope, F is where they're equal. And G? Nope, G is above g of x. And so A and E are my 2 points on f of x that are solutions for f of x being lower than g of x, less than g of x. Okay, example 4. We're going to do a second one of this because I know this is a little tricky for some people at first. We've got some other questions here for us to answer and then some repeats. Okay, I'm going to recommend pausing the video with each one, trying it on your own, and then restarting when you're ready to check your answer. But I, of course, will leave that up to you. Okay, we have this f of x graph here. How many solutions, so how many points are there lying on, right, are there for f of x equals 0? What does it mean for f of x to equal 0? Okay, f of x equals 0 at the x-intercept. So how many solutions, how many points lying on f of x are x-intercepts? F of x equals 0, x-intercepts. Well, here's 1, here's 2. Okay, go ahead and pause the video again, restart it when you're ready. How many solutions are there for f of 0? What does it mean to be f of 0? Okay, well, f of 0 is a y-intercept. Right? How many solutions are there for the y-intercept? There is 1. Okay, pause the video again, restart it when you're ready. F of 1.34, what does that equal? Okay, well, this means that, because look at where the x is, right? F of x, x equals 1.34, which is right around there. Right, that's x equals 1.34. So what is my f value, my y value, when x equals 1.34? My y value, here's my coordinate point there, is 1, 2, 3. Okay, pause the video, restart it when you're ready. D, how many times does f of x equal 3.5? AKA, how many times does y equal 3.5? Right, f of x and y are somewhat synonymous. Okay, well, let's take a look at our graph. What does y equal out here? Well, y is 3, y is still 3, y is 3, y is 3, y is 3. And now my graph is a decreasing function, right, all the way from here to here. Okay, so it's decreasing, so my y is whatever it is, it's less than 3, less than 3, less than 3, less than 3, less than 3. We hit 3 again here, and then my graph goes up to infinity. Okay, well, y equals 3.5 is right in here. How many times does f of x or y equal 3.5? One time. Okay, E, on what interval is f of x less than 1? Notice here they didn't specify what type of interval to use, but what does that inequality symbol tell me? It means that there are no points, right? Less than or equal to would mean a point. This is no point or parenthesis, right? So we are doing an open interval here, just less than 1. Okay, so on what interval is y less than 1? Well, y equals 1 right here. That's y equals 1. So when am I less than it? From this point to this point, which starts at x equals 1, 2, 3, 4, 5 and a half. Right? That's where it starts, at 5 and a half. And goes all the way till 6, 7, 8 and a half. Okay, pause the video, restart it again when you're ready. How many roots does f of x have? Okay, what does it mean to be a root? A root is the x-intercept. So it's asking me, how many x-intercepts does f of x have? Well, f of x touches the x-axis once and twice. So it has 2 roots. Okay, which, by the way, throwing this in again one more time, it makes sense that A and F have the same answer, right? How many roots, how many solutions are there for f of x equals 0? Root f of x equals 0. Notice, root and f of x equals 0. It's the same question. It's just a different way of asking it, right? It's like saying, where is the library and donde está la biblioteca, right? 2 different ways of asking the same question. And so you're going to get the same answer, right? In this case, 2. Okay, G. On what interval or intervals is f of x greater than or equal to 3? Okay, well, now we have an equal to, so now we're doing brackets. Okay. Or at least I should say we are potentially doing brackets. Okay, greater than or equal to. Okay, so y equals 3 is right in here, right? That's my y equals 3. Well, notice y equals 3 on all of this interval, which starts where? It starts out here at negative infinity. Whoa. Remember, negative infinity, never a bracket. So that's a parenthesis negative infinity. Over to, where does it end? At x equals 1, 2, 3, 4, 5. And there is a point there, so I'm going to go ahead and do a bracket, right? Equal to means I can do brackets. Okay, is there anywhere else where my y is greater than or equal to 3? Yeah, over here, this part of the graph, right, is greater than or equal to y equals 3. Okay, that starts at x equals 6, 7, 8, 9. And there is a point at 9, so I'm going to go ahead and put a bracket, because again, I'm allowed to. There's an equals. And goes all the way to infinity. Okay, last question, H. Pause the video, restart it when you're ready. Does f of x equal 0 between x equals 5 and x equals 7? Okay, well, x equals 5 is right here. X equals 7 is right here. Does f of x equal 0, aka All right, here's f of x equals 0. Do I have an x-intercept between x equals 5, this line, and x equals 7, that line? And yes, I do. It's right here. Okay, again, if there are any questions, write them off to the side. We've got one more quick little piece here that we are going to walk through. Okay, example 6 you're going to end up actually doing in class, but example 5 here, we're going to do this one together. We're going to do a couple actually together, and then I'm going to encourage you, like I have been, to pause the video and try it on your own. Okay? Directions say, the table below shows several points on two continuous functions. Let's pause there for a second, remind ourselves, what does it mean to be continuous? Okay, it means there's no break, no hole. There's never a place where I have to pick my pencil up to skip over a number, right? Continuous, meaning never ending, no breaks, stuff everywhere, right? And we have two of those, f of x and g of x. On a number line, we are going to shade the intervals between the integers where the solutions to the statement must exist. If it is not necessary that a solution exists, explain why. Okay? So on our number line, we're going to put our x values, 0, 1, 2, and 3. Okay? On your graph over here, this is an optional tool. This tool is here for those who have a little bit of trouble visualizing what's happening in the table. Some of us aren't visual people, right? And so that's fine. If you were sitting there going, I cannot see f of x at all, well then graph the points. And so let's go ahead and do that. F of x at x equals 0, f of x is -2. At x equals 1, f of x is 3. At x equals 2, f of x is 4. And at x equals 3, f of x is 1. Okay, and that's f of x there. And it's doing something. I don't actually know for the record what it's doing. All I know is it's continuous, right? Which means there's never a place where I'm going to pick my pencil up. I don't know what it does exactly. It's possible that it kind of curves like this and then comes down, right? It could show up like that. For all I know, right, these could be straight lines, like that. I mean, if we really wanted to be crazy, we could go like up and down and then hit this point, and then maybe like a whoop, hit here, and a whoop, hit there. It doesn't matter because we don't actually care. No matter how you draw this, and so for me, because I will confess I am not an especially visual person myself, and so I always like drawing things so I can see them. For me, I always draw lines. Because even lines will be enough for you to be able to answer these questions. If you want to make them kind of curvy, make them kind of curvy. Just make sure that you never pick your pencil up, okay? And that you connect these 4 points. Okay, so for A, they're asking me if my intervals are 0 to 1, which is this interval in here, 0 to 1, 1 to 2, 2 to 3. On which of those intervals do I know that my f of x is going to equal 0? Okay, and so I'm going to start graphically. For those who prefer to see it over here, what does it mean for f of x to equal 0 again? Okay, that's an x-intercept. Okay, and so on which of these intervals, 0 to 1, 1 to 2, 2 to 3, do I see an x-intercept? Well, I've got one x-intercept right here, which is between x equals 0 and x equals 1. And so I'm going to shade in there. Okay? For my people who just want to look at the table, you can answer this question without the graph. Okay? These are f of x values, -2, 3, 4, and 1. On which of these intervals from 0 to 1, 1 to 2, and 2 to 3 does 0 have to occur? Well, the only place it has to occur is in here, right? To go from -2 and to get to 3, I had to at some point cross through 0. I could have gone down to -5 and then up to 7 and then to 3, right? Like I don't know exactly what journey I took, but the only way that I could start at -2 down here and to end at 3 is to at some point equal 0. And so if you want to just look at the table, you could look at it that way. Okay, which intervals does 0 lie between? It lies between 0 and 1 here, when f of x is -2 and 3. Okay, let's go ahead and do another one together here. Again, we're going to do all 5 eventually, but again, one more time, building your number line, make sure you put your x values on your number line. Okay, now we're concerned with g of x. So for those who like the graph, go ahead and take a moment, graph your g of x. X equals 0, g of x is -6, x equals 1, g of x is -2, x equals 2, g of x is 2, and x equals 3, g of x is 4. So again, I don't know exactly how these are connected. I myself always do kind of linear in look. Although again, you can curve them if you want, as long as you don't pick your pencil up starting at this point going to this point, and as long as you hit all the points in between in the process. Okay? So B, where does g of x have to equal 1? Okay, let's do the table first on this one for those who prefer tables. So g of x, here's g of x, on which of these intervals from 0 to 1, 1 to 2, or 2 to 3, does my g of x have to equal 1? Well, here it doesn't have to, right? I could go from -6 to -2, -6, -5, -4, -3, -2, and I would never hit 1. What about the second interval? Yeah, I would have to hit 1 there, right? The only way I can get from -2 to 2 is to at some point pass through 1, right? I could have gone down first, like -2, -3, -4, but then I'd have to come back up, -3, -2, -1, 0, 1, 2. And right there, 1, 2. At some point, whatever my graph is doing in between here, I have to have passed through 1. 1 is between these two numbers. And so my interval from 1 to 2 is one of the ones I'm going to be shading. What about this last one? Does g of x have to equal 1 here? No. I could go 2, 3, 4, and never hit 1. Okay? For those who want to do it on the graph, g of x equals 1 would be this line. Grab a pencil real quick. Would be this line right here. Okay, well, g of x equals that line, 1 right there, and that's the only time it touches that line, which is between x equals 1 and x equals 2. And so that's why I shaded there. Okay? Okay, if you feel like you've got it with that, go ahead and pause the video, try the next 3 on your own. Or if you feel like you'd like to maybe watch one more or so, but again, at some point, start practicing it on your own. Okay, f of x equals g of x. So we've got our number line here, 0, 1, 2, 3, which again are the x values. Okay, where would f of x have to equal g of x? Okay, we'll do graph this time first, right? So I'm going to keep switching back and forth. Okay, graph this time first. What does it mean for f of x to equal g of x again? Okay, it means they touch each other. This means they touch each other. Where does f of x and g of x touch? One time, right in here, which is between x equals 2 and x equals 3. Okay, for those who prefer the table, not the graph, this one I will say is a little bit trickier at first to do with the table, although you definitely can get it. Okay, the question is, who is below the other, right? If one function, in this case we can see it graphically, if one function g of x is below f of x, then we know that they were at some point equal when the function that was below becomes above, when the function that was less than becomes greater than. Okay? Right? Since g of x was below and then was above, at some point it had to cross through. Right? It had to cross over to switch from being below to being above. Okay, so let's take a look here so we can see where this would be. Initially, who's greater? Okay, well initially, f of x is bigger. Next one, who's bigger? F of x is still bigger, right? So didn't necessarily equal in between here. F of x was above, f of x was above again. I don't know that they crossed over. Right? What about the next interval? Well, that's above. So still didn't cross over. And what about the last one? Oh, now g of x bigger. And so in this interval where we switched from f of x being greater to g of x being greater, okay, they had to have at some point been equal, sometime between 2 and 3. Okay. D, again, if you haven't already, I recommend pausing the video, trying this one on your own. Okay, g of x equaling 0. On what interval do we know g of x equals 0? Okay, well, I'm going to go ahead and do the table first this time. Okay, so g of x equaling 0, g of x was negative 6 to negative 2. We did not have to cross through 0, so not the first interval. Second interval, negative 2 to 2. Oh, right there. The only way to get from negative 2 to 2 is to at some point pass through 0. So my interval 1 to 2 is one of my intervals. Okay. 2 to 3. What about 2 to 3 here? So 2 to 4. Do I have to pass through 0? Nope. Okay, and so my answer is just the one interval. We're looking at this graphically. G of x equals 0 means an x-intercept. My one x-intercept for g of x is right here, which is between x equals 1 and x equals 2. Okay, last one. One more time. Pause the video. Try it on your own first. Okay, f of x equals 5. Right? Well, take a look at our f of x here. Between negative 2 and 3, did I have to pass through 5? Nope. 3 and 4? Nope. 4 to 1? Nope. And so there is no place here where 5 is necessarily going to happen. Graphically, you can see that here, right? F of x equals 5, 1, 2, 3, 4, 5 is up here. Here's my f of x equaling 5 up here. Did f of x ever touch that? No. Okay, and so it's not necessary. And then some sort of reason. Why is it not necessary? Because, and it's something like, again, there are a variety of explanations, so if you want to check yours, run it by your teacher. Okay, but it would be something like, not necessary because no given value of f of x is greater than 4. Or something like that. Again, right, there's lots of ways of explaining, but none of my f of x's are even greater than 4. They're all less than 4, or I should say 4 or less. And so we wouldn't necessarily have a place where we ever equaled 5. We don't even have anything necessarily that's above 4, right? Okay, again, if there are any questions, write them down now.